Hi friends, welcome to our channel Education Hub. Today's our topic is 8085 instruction sets. ये 8085 है क्या? It's an Intel 8-bit microprocessor. यहाँ पे बहुत सारे instruction sets हैं. We will describe grouped under the 5 different functions. See here, data transfer group generally moves the data between memory location, registers including moves, loads, stores, exchange. Arithmetic for addition, subtraction, increment, decrement data memory from register or memory. Logical for and or not, rotate, complement data in register or between memory or a register. Branch for jump, call, return and restart. Stack IO, this is the control. These are the stack, etc. purpose. Let's start the first one. They're the data transfer instruction. By the name you can able to get. मतलब अपने name से ही पता चल रहा है. For instructions data जो कहीं से भी कहीं move हो रहा है उसे हम लोग data transfer कह रहे हैं. It's a condition flags used here, not affected by any instruction in this group. Group instruction here transfer data and from register and memory. See here, generally all the data records instructions while copying content from source are not modified. These are called data transfer. First ones the coming is move. Generally purpose to move. Here see here, the operands is written RD, RS, MRS, RDM. These are means register. Here, the second one what is written, therefrom it is copied and moved to the first one. So first one RS copied to RS moved to RD. RS moved to memory, second one. And third one, memory moved to RD. So you have to remember that thing, that the first one will be get the value and second one values will be transferred. That is nothing but move. Now our next one instruction. Here this opcode, these are our instruction. First we are writing MVI. Here what is? It is move immediate. Where it is C RD data or M data, that means data will be immediately moved to the register or moved to the memory. It is 8-bit. Next one is coming LDA. LDA is the purpose that will give you the load accumulator. Here the values will be loaded to the accumulator immediately. This is 16-bit address. It is loaded. See here the examples is also given. LDA 2034H. Next one is coming LDAX. LDAX means load accumulator indirect. Load accumulator indirect means it is generally the register pair loaded to the values of data or any values to the register pair. I think it is clear right now. Generally load to accumulator indirect. If it is LDA, then it will directly addressed. Load accumulator direct. It is X, that is our indirect. Now let's go on. LI, LH, LD, that is H to L, that is load to the register directly. Here it copies the content of next memory location into the register H, that is HLLD. Sorry, LHLD. The examples is given also here. Now the next one we will discuss, that is, before that, one thing I have to tell you, please don't skip it because every instructions is very important for there. Now STA. STA is which purpose? STA is used for generally store accumulator direct. Whatever the values is there, you have to store it into the directly to the accumulator, then you use it. Generally, it contains the accumulator copied into the memory location specified by the content of the register pair. You can see this. Next, SHLD. Generally, SHLD used for store HL register directly. Already we discussed indirectly, here it is directly. Here the content of register L is moved to the memory location whose address is specified by the byte of 2 or 3. This content, the register H, is moved succeed by the memory location. Now next one, XCHG. Next one, SPHL. Here the copy HL pair, stack pointer SP. These are the used for, the example is given, SPHL. Next, we will start discussion over XTHL. This is exchange of HL with the top of stack. Here the content of H are exchanged with the next SP plus 1. Here also the data transfer is going on. The PCHL. PCHL, generally its content, the H and L are copied into the program counter. That means all the values of H and L will be copied to the program counter PC. Here you can see the example, only PCHL. Whatever the values in the registers H and L, it will be copied to PC. Next, we will start our discussion over PCHL. Here the discussion topic. Up to this level we stop. We had telling you don't skip, because if you skip you can't able to get all the instructions. Now push. By the name it is very familiar. Push register pair onto the stack. Now on the stack related topic, if you forget, then you can follow our from the playlist that all are given there. Therefrom you can follow. Here the memory register or lower order registers or higher order registers details also, if you have to read, you can read it from our playlist architectural notes. Now pop is also for pop the stack register pair. So push pop, that is the stack operations, you are familiar with that. So there also this data also transferred by this type of instructions in 8085. Now out, this copied the accumulator into the port with 8-bit address. Here the content of the accumulator copied into the IO port, output port, input output port with the command or opcode out. The out example you can see, the in is just opposite, that is the content of IO port are copied to the accumulator. Whatever in is given, that is copied to the accumulator. Here also the examples is given in 8CH. Now let's start with the arithmetic instructions. Arithmetic instructions generally एडिशन सब्ट्रैक्शन ये सब है. यहाँ पे 8 additions is known as 8-bit registers be added directly. Now here 8-bit number or the content of the register or content of the memory location can be added to the content of accumulator. जनरली एडिशन के पर्पस में हम लोग ये चीज़ यूज़ करते हैं. So if I use it now, how can I do this operations? We will discuss it right now. Subtraction, obviously हम लोगों को पता है, we know this. Computer cannot subtract directly. By using 2's complement form, we will do this. The 2's complement, if you forget, you can study from our digital electronics notes. Now increment, decrement, these are the increment and decrement operations. 16 Now the arithmetic purpose, addition, the code is add RM. This add register or memory to the accumulator. Similar for subtraction purpose. Also we will see this. Just see it. From the screen, please follow it, as because I told it several times. If you read it from the screen, it will be better for us to get. Now ADC, it is also add register to memory accumulator with the carry. If you have carry, then also you will do this. Now see the next one, add means directly adding. If you have carry, then you will use the ADC. Now ADI will tell you that 8-bit data add to immediately to the accumulator. Now whenever, what is this difference between ADD, ADC and ADI? This concept you have to be cleared. ADD is telling only to add. If there is carry, you cannot do this. If the carry operation is there, ADC we need. And if you need immediately, you have to 8-bit data add to the content to the accumulator, then you need ADI. So ADD, ADC, ADI, these are the purpose of addition. Now ACI is also there. ACI will tell you add immediate to the accumulator with carry. If immediately you have to do and there is also the carry part is there, then you have to do this ADC. Now this is coming DAD. This is telling add register pair to HL pair. What is that? That is, if the 16-bit of register pair are added to the content of HL pair, then it will be called DAD opcode. By using DADC, here the examples is given DADB. Now sub RM means subtraction register or memory from accumulator. Here also the examples is given. Now SBB, subtraction register accumulator with borrow. This, what is borrow? This concept you can get also from the digital electronics, our notes. From playlist you can follow it. SUI. Next one. SUI means it will tell you subtract immediate from the accumulator. So SBB means with borrow, SUI means here immediate accumulator. So again I am telling you that if you are go through just like add, the subtraction also you have several. So SUI, once again I am telling subtract immediate from the accumulator. It will do the immediate operation. Now the next one we have to discuss. Before that I am telling SUI 45H is the example of SUI. That means immediately the values will be subtracted from the accumulator. Now next one, that is SBI. Here the 8-bit data subtract immediate from the accumulator with borrow. So just like the previous ones also, it will do immediate subtraction from accumulator, but there also follow the borrow part. Here the borrow flag will be also CY, that is borrow flag will be subtracted from the content of the accumulator. So I think these all subtraction part is also clear to you. Right now IRR. IRR telling you INR. INR will tell you that is content of the register or memory location are incremented by 1 or decrement. INR means increment. If I have to decrement, just the opposite will come. Before that increment we have to check. If the increment register pair we need, there I have to, it is the increment register or memory, both are possible. See it, INR. Now we will discuss INX. Here increment register pair by 1. If register pair is only, then INX, and if INR, that means register or memory pair. I think it is clear right now to you. This is the part of increment. Now we will come to the decrement part. For the decrement part, before that, make it clear. INR means register and memory. INX, increment register pair by 1. DCR, here see this, decrement register or memory by 1. That means the content of the register or memory location will be decremented by 1. So this is DCR. INR, just opposite of INR. INR increment, DCR decrement. Okay, I think it is clear. Now if it is DCX, that means decrement of register pair only. INX, DNX, DCX. I think it is clear right now. So this up to this level was arithmetic. Now we will start our discussion over logical instructions. Now the logical instructions, already I told you, here I only mentioned and, or, XOR, rotate, compare, complement, etc. Now for add operation, 8-bit data or content of the register or memory location can be logically got this operations. Obviously and operations we are familiar, and operations means there only the dot product will become, or operation, XOR operation, that means any of the output gives 1, then only. Then compare, for comparing purpose, equality, greater than, lesser than, these all also we can compare. Here the comparison is possible with the content of the accumulator. Now for that purpose there the result of if reflected status flag will be applicable. Next, we have to discuss about for logical and or not, then comparison, then complement part is coming. For that, the complement, we know it very much that the content of accumulator, whatever the values, that will be replaced by 0 by 1, 1 by 0, that is nothing but complement. Now let's start the discussion of one by one of code. First one for comparison purpose is coming, that is CMP. By the name you can get, CMP means compare register or memory with the accumulator. Here whatever the register or memory locations value is there, that operand will be compared with the content value of accumulator, and if the both content are preserved, the result of the comparison will shown by the stating flag of PSW. See here, I am showing you the PSW. If you can follow the screen, just it will come CMP RM. If A is greater than or lesser than whatever the signal will become, register or memory, then carry flag is set, carry flag reset. If it is lesser than, then the carry flag is set. If it is equal, then the flag is set. Flag 0, 0 flag is set. If it is greater than, then the carry flag is set. Now CPI. CPI compare immediately with the accumulator. So after this level you can able to get when the I is coming, that means immediate operation purpose. It will also give you the same thing, carry flag, 0 flag, carry and 0 flag reset. Both are set, then reset. See the operations. Lesser than, equal to, greater than. Lesser than means carry flag set, 0 flag set, then. Now the next one is coming, ANA. ANA, that is the logical AND of register memory with the accumulator. Whatever the content is there up to the accumulator, that will be logically ANDed. That means dot producted to the content of register and memory. ANI, that is the immediate operation. I means immediate. The logical AND operation, immediate with the accumulator. The same thing. Now XRA. XRA tell you exclusive or XOR register memory with the accumulator. That means the same thing, accumulator will be give the immediate, not only immediate, that is the XOR operation to the value. Next, ORA. ORA, that means logical or register or memory with the accumulator. See here, XOR operation, you know it, when any one is value is give you the 0, 0 and 1, 1 or 0, then only it will gives you the positive reply. And for OR operation, that is also, you know, any of the values, if you give 1, then also it will gives you the 1. Here also the same thing will come to our side. See. Now, so ORA, I think it is right now clear to you. ORA, that is logical or register or memory with the accumulator. Next one is coming ORI. ORI means RI. I is coming means immediate, the logical or immediate with the accumulator. So after this level, I think clear. Next we are coming XRA. What is XRA? That is logical XOR register or memory with the accumulator. See here from the screen. In screen, by pausing the screen, you can write down all the opcode because all the opcode is also very necessary for you. Follow the lecture. Along with that, please take the screens of code and their description. Then you can able to get all the register instructions codes. See here, XRA is given. I already told you XRA means logical XOR register or memory with the accumulator. So logical XOR memory, after that XRI will come, means immediate to the accumulator. XOR operation immediate with the accumulator. I think right now you can able to see when the I is coming. RLC, that is rotate accumulator left. RLC, rotate accumulator left. RRC, rotate accumulator right. Rotate accumulator right. RAL, rotate accumulator left through carry. Left through carry. RAR, rotate accumulator with carry but right side. RAL means left side, RAR means right side. That way you can able to remember. So next one, our logical, that is coming CMA, complement accumulator. Complement accumulator means here the content of the accumulator is complemented. See the screen, it will come. Complement accumulator, that means our CMA. Now you can see this all instructions or the opcodes is coming to your side. If you able to remember, then in practical whatever you have to do, this command you don't have to redo. Just once you go through and memorize it, you can able to handle it by any simulator or any kit. See here, CMA is coming, that is the complement of accumulator. What the next CMC, the complement carry, that is it will carry the flag is complemented. Carry the flag complemented means no other flag will be affected. Whatever the carry flag is there, that will be just complemented. Now STC, set carry. STC is set carry. After this much, we read the logical instructions. Right now, we will try to learn the all branching instructions. Before starting the branching instructions, once again I am telling you that all these instructions you have to follow and you have to write down for any type of practical. So there, if it is doing simulator or anywhere, please remember these instructions. Now the branching instructions is coming. By the name you can able to see the branching purpose. Branching alter the normal sequential flow, you need it. First one is JMP, that is jump unconditionally, we need it. Next JX, that is jump conditionally, 16-bit addresses. If any condition will satisfy, then only it will jump. Here the all details is given: JC, JNC, JP, JM, JZ, JNZ, JPE, JPO. All their descriptions is also given on the screen. You can follow it. Jump if carry, no carry, positive, minus, 0, non-zero, parity, even, parity odd, for all purposes. Please go through it. You can pause the video and write down it. It will be better for you. Now, one thing I have to tell you, here the flag value, status flag value is also take a big role. So if you have to remember, you have to remember that flag, status flags also. So if you write down, you have to write down the opcode, their descriptions and their flags details. Now first one is coming call, that is call unconditionally. If it is CALL, that is unconditionally. Now whenever the X is coming, just like there I, here it is X is coming, that means call immediately. Here also all the call conditions I will tell you one by one. You have to write down the opcode, the descriptions and flag status. CCmin, call if carry, when the status is CY is 1. CNC, call if no carry, then the CY is 0. No carry, that is 0 should be. CP, call if positive. If it is positive, so no S0 will be S equal to 0. If minus, then S equal to 1. Similar, call if 0, Z equal to 1. Call if no 0, Z equal to 0. That way all the flag value will be given. Now the branching purpose is return value RET, that is return unconditionally. Obviously if it is RX is coming, then call conditionally. There are, sorry, not call, return conditionally. So this here also I will tell you all the return values and their details. In the screen you can get Rx equal to tell you call conditionally, it will be return conditionally. Please follow it. Now here all the details is given. I once again tell you, if you want to remember, then please pause the video and write down it, because it is necessary for you. Because if you just go through, whenever you will operate, there also you, from this video you can recheck it. Now the next one, I have to tell you the branching instruction, that is nothing but RST, that is restart purposes. See here, RST, it is restart the software interrupt. It is, you know it, you can learn it from the lecture, that there are 8 software interrupt in 8085. See here, 0 through 7, all the instructions is given. Here the restart addresses and 8 interrupts is given here. See from the screen, RST0 to RST7. Now about ending the lecture, the control instructions is coming. Control instructions for controlling the operation of microprocessor. That is nothing but using the ultimate instructions. Restart and control instructions, these are very vital. Now for the control instructions, whenever no operation is performed, that is NOP, no operation. HLT, that is hold operation. Halt, you finish executing the current instructions, now halt for the further instruction. Next one, DI, that is disable interrupt. After completion of the work, disable it, that is trap are disabled here. So up to this, I think it is clear to you. Next, SIM, that is set interrupt mask. What is that? And you have to, at the end I have to tell you, if you like the video, don't forget to like, share our video and subscribe our channel. Thank you for listening this video.